So we're good to go. Where were we? Okay, so I think I was almost done. I think I was basically I got these results, and now I need a way to understand which coefficient I can put where in the cubo, and this is a problem because basically the coefs tells me they tell me what's the exponential of each of the 6 coefficients, but it doesn't tell me which one it is. I'm assuming it's, the 0.07 coefficient is something. Yeah. So that's this one here, right? So this is basically the x000. Maybe they are in order. Could that be that this is the first position? No, wait a second. That the no, that's not true. So these positions must make reference to these coefficients, but then we need to know. This means this coefficient is related to. Sorry, these. What's the? Yeah, this coefficient is corresponding to this monomial, and this what tells us is it's sort of a way to codify the monomials. But I want to understand. I need to know which monomial we're talking about, so I can put it into the right place in the matrix, in the cubo, right? Because the cubo has to be like, in the diagonals, there's just the x000, x001, etc., etc. And here we have, because here it's always basically this is n, this is t, and this is q, right? So q is always going to be 1 in this case, because nq is 1. And t is 2, so it's going to be 1 and 2, and then 3 is going to be, so it's going to be 0, 0, 1, 0, 1, 1. So it's going to be like 0 and 1. So it's not like, and so all these go into the diagonal. So actually have to build, I have to build a matrix based on these as well. Or let's put it this way. The way that I should probably def generate cubo, right? And that also is a function of, so this is a function of n and q. I don't need k, I need n and q and NQ and NT. So I need these. And then what I should do is I should basically, for n range n, then, here goes whatever to do, and then here goes for t in range NT, and I'm doing it like this because that's the way that I'm codifying it here as well. That doesn't really matter as long as I know, as long as I can be, I know how to reconstruct this, and I then know how can I need to be able to figure out what's the, which is the monomial and the coefficient. Then this is basically to do, and then it's for q in n in range nq, right? To do, and then that's basically it. And so here we just, return Q. And so Q is basically an NumPy array of what? Of, to be honest, it's of what will the dimensions be, right? It's n tot times n tot, right? I think that is what you, so it's basically n times nt times nq, n times nt times nq, because that's the number of qubits you're going to have, and you want to have like if you're going to have like, say 3 qubits, you're going to have a 3 by 3 matrix. So and that is n tot. Okay, cool. And so you return Q or something like this. I guess that's the idea, right? What happens if I'm not sure if factor is the right thing to use. This makes SymPy tutorial. That's going to be a what's the maybe I should go through these more interesting example. Why SymPy? No, that we wrote. No. So these are examples. The power of symbolic computation. Factor. So here's factor. But you see, factor. This is the factored form. Oh, wait a second. There's something called expand. Did I use this before? Can try that as well. Yeah, but that was not the point. I actually wanted to comment this out for a second and print the generate Cubo thing. Should do this first. Get NumPy and SymPy. Wrong indenting. Wrong indenting. Why? So what have I done wrong here? Return Q. Expected an indented block. Oh, maybe it's because I have these loops empty. Data type not understood. What? It's an NP array. Print Q. Can I not just call? Okay, what about I don't print these, but I just call generate Cubo. and that prints me. That's not the right way to specify an array, or what? NP create array. NP numpy. Oh, I could do something like zeros. Okay. Zeros, and then how does it work? And then I still have to do like this, give it a tuple. Oh, there you go. Okay, cool. So that kind of gives me the cubo. Well, and I need, I guess, what I need to give it is I need to give it the expression, right? Probably. Because that's what I will need to actually build a thing. Or expression to cubo. Something like that. Oh, come on. Generate cubo. I'm not gonna spend too much time with the namings here. Okay. Where was I? So I was here. So now we're trying to understand how does this look like. So let me run this again. Well, that was fast now. Okay, cool. 0.12 is x to the so it's like the 000 to the power of 2. So that kind of, I think it makes sense that those are, so 0.15. But you see, that's funny because it's not like, these are not somewhat like somehow ordered by like what's the biggest coefficient, like what's the monomial with the, you know, with the biggest exponent. Because 0.15 is this one here. It's the only one. Or this one here. This we don't know. It's definitely these and these, but we don't really know. Okay, so can I know? So poly and what I want to know. So I want to know whether I can find specific elements, because this is, I'm turning this into a poly object, like as a polynomial expression, and then taking the coefficients and the monomials. And I want to know, those are the monomials. But I want to know the symbols. So simpy get monomials and symbols. So what simpy do I have? Monomials. Exactly, so you will get, yeah, that's what we're getting. SymPy prod. Okay, so here. So they're saying, so you're getting the powers, but then you're also putting everything into a dictionary. I think that's what you're doing with Zeep. What you're doing is SymPy prod. For XK in Zeep var. No, that's not what Zeep is doing. For mon in powers. So for each monomial, like the 2, 0 here, you're doing okay, so you actually need these vars. Yeah. So then this will work. First symbols and first symbols in the domain which return the sets A, B, C, X, and however, then we are faced with the issue with the set, that the sets are unordered, hence converting it into a list might mess up the order. The property gens show the generator holds a tuple of variables in the polynomial. Okay. Interesting. Oh. Now I end up, but I checked that before, so I don't know why it didn't do this. So gens generators, also tuple of variables. So if I do say print these gens, I hope the video is getting through smooth. Encoding overloaded. It's warning me all the time. But yeah, sorry. I'll probably, if this video ends up being crappy again with the video, I'll have to figure out again what's wrong with the setup. Now it's not warning me anymore. Anyway, so what does this give me? I can't print a tuple. Oh, it's not a function actually. Oh, come on. Oh, there you go. So so this is the order of things. This is it. Okay, that's awesome. That is awesome, actually. So basically, this is telling me that, yeah, that this element here, which is 0.18, it's 0, 0, 0 times 1, 0, 0. So this one here. Yeah. Okay, cool. Now, how do I deal with these? So I probably if I do this and I say, well, now what have I just copied? So I'm expanding these and I get like monomials. Is these? Oh, come on. Come on. So I had it right there. Good. So I'll even do it everything like here. So finally we expand it, we turn it into a poly, and so now what we do is we do H. So what does this do is it creates a list for each of the monomials in monoms. It iterates over the generators and the monomials. don't understand why this works. I don't like that, but so coefficients is basically h coefs, and so now we now have is prod is not defined. It's probably sp prod. Okay, so now we have so what do we have now? Yeah, so we have each of those components in here. Now I can tweak this to my advantage because I don't care whether this is like to the power of 2 or not. I only care whether they're alone or, you know, in pairs. So I can actually shouldn't I just or can I not just like how do I tweak these? So for each monomial in that order, you're... What is Z doing in Python? Returns an iterable of tuples. Any example, please? 1 to 3, 1 to 3, so... number list and string list. Okay, so it just creates a list of these values combined. So what this is doing is for each monomial in Monosis, that like object that had the exponents and stuff, it zips together all the generators, or each generator. We just saw that there. Okay, with the monomial and x times k, but the monomial was in of itself a tuple. So I don't really understand that. How can this work at all? Like, if I take these and I'll do it monomials 2, and I just want I'll just ignore that and I print monomials and monomials 2. What do I get? Oh god. I should actually print something like this here as well. To the power. Well, this I definitely don't understand. Ah, oh, that's smart. Okay, I get it. Oh, okay, I get it. So it's saying to the power of k because then it's doing it using the SymPy product. So it's gonna everything that's to the power of 0, it will just be reduced. So it will just be removed, and so you're just left with the right monomial in here. Uh-huh. Mm. How do I? How do I get these? Because ideally this should be simplified enough that this doesn't appear anywhere else. The 0, 0, 0 alone. No, actually, I'm wrong, because that could appear somewhere else as well. And what happens if I would have two monomials, like one x 0, 0, 0 and another one x 0, 0, 0 to the power of 2? Do I need to get the coefficients and add them both in the same spot in the cubo? Probably. But how do I deal with these here? Now, how do I get... So this is an array of expressions at the end of the day. That's what we're getting here. And I want to then iterate over these. So I have the coefficients, I have the monomials. I want to iterate over these, over the coefficients, then take the proper monomial. And then basically I would know, or the other way around. I want to... So I don't need the expression, I need to give it the monomials and the coefficients. Or I can just do it here, so I can actually really give it the expression, or give it the poly. And actually, basically, calculate this inside the function, because we only care about this here. So this is poly. Oh, just, let's go with h. Come on, h. And so what I just need here is to, yeah, basically the cubo is this, and then print cubo. That's all I want to do, right? And so everything else in here I'm taking inside the function. The rest down there. So where are we now? Let me see. The monomials, the monomials. Actually, let's take it back here. Don't need to run the expression. I don't care about running the expression. But I do have to start the pretty printing here. Okay, now we have these parts. So we have the thing which generates the cubo and prints the cubo, which is basically just Is it that big? Oh, it's 2 row. 2 times the cube of y. Oh, I'm putting it here. Sorry. Okay. Okay, so now we're good. So let's print the cube. Now what I have to do is I'm here, and so as I iterate over these, I need to well basically say that now I'm looking for element I don't know. Ah, I need to map the elements in of the matrix, like the diagonal elements are. Yeah, so this nested loop would actually fill in the diagonal elements. Cool. Yeah, that's what it should do. Let's see. let's start here. Okay, so that should fill up the diagonal elements. So basically now, like I have the string, so so the monomial the m label should be basically x underscore well these, right? Basically. So this is what the label should be. Let's print m label and see what happens. Yeah, so those are the things in here. Cool. And now I just need to grab the coefficients of these things. So how would I do that? So so that's where I say let's iterate over the monomials, right? So for mon in range monomials, so I have basically mon equals monomials I. So I have the monomial here. If I'll print mon, what do I get? Yeah, these things. Okay, cool. How can I just, because that's a symbol, right? Oh, it's an expression. What if I turn that into? Yeah. What if I turn that into a poly as well? So I say sp poly, and I basically say print the generators of these. Yes, I like it. Cool. Cool. Awesome. Yeah. That's awesome, actually. Let me just for the sake of testing these. If I print this here, I just want to print it once. Okay, so I make sure that it gives me the right thing that I want. Because it's pretty big, but I see the 000 again here and here. gens. So first is the 0, 0, 0, then is 0, 0, 0, and 1, 0, 0. Then is 0, 0, and 200. Oh yeah, then it appears again. Okay, so I guess these things will just have to be added. I hope so. Is this because of the way? So if I print H in here, yeah, it appears here. Here appears. Okay, so I guess I would have to add those things. I think so. I don't know. It's a question, right? So we should write this question somewhere. It's an open question. But let's take this back where it was. So I have something I'm happy with in terms of these. Now I have the monomial. But this is a tuple, right, or something. So how can I... I should basically... I should turn these into... I should now turn this into a... What should I do now? So I'm going through the monomials, and now I have this monomial. So if I click the... If I call gen... If I print the gens, it gives me these. If I now... take the gens. Can I take the gens and I say for j in range? So first of all, gens equals 1 gens, and so if I iterate over these the generators and I gens string is basically an empty string. And now what I just do is gen string is I append gens j, and at the end of the whole thing I print the gens string. Can I do that? No, I cannot do that. Simple to string. Yeah. SymPy symbol to string parsing. Parse expression, that's not what I want. I want to compare get symbol name. String, maybe I can convert it simply by just doing these. So turning this into a string. Oh yeah, okay, that works. That works, I like that. Okay, cool. I just probably, if j is smaller than the length of gens minus 1, then I probably want to concatenate with a star symbol, right? So I forgot the semicolon. Yeah, I don't know if I'm not over. What? What? Well, obviously j bigger than 0. N. Is it like these n or these n in Python? And obviously, this is what we're looking for. Yeah, there we go. So you have this times thing here. I don't know. There should be. I feel there should be easier ways to do this. What am I doing? So I'm iterating over the monomials. Then basically for each monomial, I don't know if I'm doing the right thing. That's not, I shouldn't be doing this. So actually, I shouldn't be doing this, I think. No, I shouldn't be doing this. So what I should be doing is, first let's focus on the diagonal. So if chance equals, like how do, what happened here? What happened here? So if I am turning, I want to turn Python list into an array. How do I do this? At least, not at least a tuple. Because I think those are tuples. Tuple into an array. My tuple, yeah. As array, okay, cool. So np as array, and then I do mon_gens, and then I print gens. What do I get? Cool, I get the arrays. That's awesome. Now, you know what? I know what I'm missing actually. I'm missing. Yeah. So what I should do is I actually am generating the diagonal labels. That's what I should be doing, which is basically np an np array, and then what I'm doing is I should append. No, I should append diag labels and m label. That's what I should be doing, and these kind of goes out of that. And what I should be what I should be doing is I should be printing the diac labels, right? Yeah, those are the labels, and they're in the exact order I want them to be in the diagonal. Yeah, exactly. So because that's going to help me map the things, right? Because I know, okay, that's cool. I have the diac labels and the diagonal labels, and so now what I have to do is now I have to go ahead with the idea here of what I was doing. I was iterating over the monomials, and I was saying basically, well, actually, I think I might be able to populate everything at the same time. So now for j in range length of the generators. So I'm going to iterate over the generators, which are arrays. Are they? I'm iterating over the monomials. For each monomial, exactly. I can get the coefficient. So the coefficient C is basically the corresponding coefficients I, right? So I have the coefficient that I want to add, and now I have also the generators, which is an array. And so now what I do is I go over the generators and I say, well, what are the indices that I need to, yeah, so what is the, basically, the cubo I and the cubo j, right? So the cubo I would be, what I'm now saying is, because I'm gonna have maximum 2, right? I'm not gonna have 3 qubits. Like, I'm not gonna have a coefficient where we're gonna see 3 different terms multiplied. It's always gonna be like j is gonna be always 2. So maybe I should ensure these by just, you know, by just basically saying, well, basically by just saying if the length of gens is bigger than 1, or is 1, then I know that the other way around. So I know that cubo I and cubo j will be at least, because this, we know there's one coefficient, so we know that this is going to be so so there's going to be the coefficient. So it's gonna what I so I need the monomial. No, I'm iterating over the monomials and the generators, and I need to know the index. How can I find the index in a? So numpy find index in array. I want to find the index given a value. This is lagging again a lot. The first index is something. That's what I'm looking for. Okay, where array equals item. That's what you do. Okay, cool. So, np where and the diag labels equal str gens 0. I know there's always going to be one element. I know this is going to be always like these. So this is going to be defined like the same, but if the length is more than 1, it means that the whole cuboj here actually needs to be the second term. Cool. So, and now what I need to do is I need to basically say, well, dear friends, and in the cubo element cubo I cubo j place or like add cubo c. I don't know if this is gonna work. Okay, that should work. Let's see. Boo. Add. Where's add? Coerced type could be according to the same kind. Okay. Q is an array of zeros. Yeah, and QOC. What is QOC? So print cubo I cubo j cubo c. Oh, array. What is that? Okay, so it seems like that's the problem. That is somewhat an array. So that's correct, it makes sense, but those indices are wrong. Like, so what is these? Maybe I should just do these. Well, it's still an array. I get 0, 0. So I should. What does where give me back? Oh, just index? Oh no, okay, no, sorry. Oh, yeah, it's a tuple with first all the row. I should have read farther. So 0, 0. So it's a tuple with first all the row indices, then all the column indices. It's just two-dimensional. So I should do basically these. Okay. Still some of those. It's an array. Still all of those. Some of those are not really. Well, give me a second. So, what if I print these? Print these and then print these. Sorry. Chance 1. think the problem is happening in here. Can I just print gens? Oh, I'm stupid. Okay. So I'm stupid. I just should basically add this here too. Okay, now we got it. We basically have this, and so that should populate the matrix. Those are literally the spots in the matrix that we want. Should probably write some tests for these though. Cool. So if I do this, and now I run that. Okay, nice. Now let's see if that makes sense. I mean, one thing that makes sense is that it's a diagonal matrix. Nice. Right, because we really shouldn't be getting terms that are like multiplied, but it could happen here. But it should be a diagonal matrix, and it is, and that's nice. Now, the diagonal elements should be negative, and they are. But this, apart from this one, which is 0, I don't know why. Now, let's see if we can really check that. So let me. We'll print. We're printing age. We're printing. Something here to separate these guys a bit more visually. I thought it would print things nicely, but okay. So, but I think we pretty much have it. Cool. Now, for example, yeah, how do I know now? So I want to print also the. Can I print these diagonal labels in here for a second? Just to double check. So those are the labels. This means that, for example, if we pick this one, right? So this is this label now. So where do we have it? So we have it alone in here, 0.04, and we have it alone in here and in here. So basically plus 0.1 minus 0.1, sort of, this is close to 0. Yeah, I think this could be, this could definitely be. So if I, can I open the calculator? Rechner in German. And I, it's funny because I have a Jupyter notebook here with me, and I'm just opening the calculator. That's awesome. Insert cell below. Yeah, I'm quite sure again the recording won't look the nicest. I don't know. I have the impression everything is locked, and I'm really running out of patience with this. But anyway, so if I print, or not print, I don't need to print anything. I can just do 0. Or let's just be exact. Okay, so we'll take these. We'll minus these, and then we'll. Yeah, that's it, really, because this is actually not a single term. So that's the only place where we have those. And this gives me minus 0.00263, which is exactly that part here. So this is working as expected. Now, what about the terms that are multiplying? So this term here is basically 0, 1, 2, and 0 and 2. So it should be like, no, what should this be? Oh yeah, this should be basically the 0, 0, 0 times 0 and 0. So if I do 0 times like x1, 0, 0, that's just this term here, which makes sense. And it's exactly this one. So I think this works well. I think the idea works well here. So basically what I did is I created the diagonal labels as a reference, and then I'm just going through the polynomials, through the generators, and then saying, okay, so dear generator, where are you in the diagonal labels? What's your index in there? And so that's going to tell me what your position is, and assuming that it's always going to be either 1 or 2 elements, then I can also know where are you in the off diagonal. Then it looks like we're ready to go. Again, I'm not done with the full cubo. Okay, so I'm missing still the costs component, and so the transaction costs, and I'm missing also the constraint of the budget. But what I wanted to do is I wanted to get this part done, because it really felt just like bureaucracy right now at the moment. So just getting the basics of how to construct a cubo out of these. And then now actually I think I have to install D-Wave. I think I never finished installing D-Wave. So let me go to actually, let me open up the other browser, because I think I had, so D-Wave, you won't see these now, but like D-Wave SDK install, because I downloaded it, but I didn't set it up, and I wanted to probably do this now and then finish the video for today. And so the next one can just be then focused on the two loss parts of the equation, and then we're ready to go. And then what we can do is we can focus on the other parts of the paper, the VQE, and all this other stuff that's going to be also really exciting. Okay, install Ocean software. Where am I right now? So no, let me put this back here. Copy the URL instead, and then, you know, if this gets into a place where I have to input some private stuff, then I'll move this away from the recording screen. But right now we have these. So I've installed that. Now set up the environment, the D-Wave setup. This is what I have to follow. So if I need to open another Anaconda thing here. So Anaconda 3 PowerShell. I'm happy that it seems to work, because the cubo, and it's even diagonal, so I hope that it was not just lucky. Okay, so I'm here now. Let's go to the workspace. It doesn't matter, I don't have to be in portfolio, but actually git status, I should probably commit all these. Git add, git commit, basic cubo building blocks. Okay, push. So at least I've committed that, and what I should just now do is I should just do the D-Wave setup. So D-Wave setup, or setup, is it like this? Yeah, let's see what happens. Let's see what happens. So it's supposed to ask me whether I uninstall non-open source packages. Yes, the D-Wave drivers, problem inspector, blah blah blah. Okay, so I want to install yes. The terms of license will install yes. Installing D-Wave drivers, cool. Contribution tools, we are not so much. Okay, this package is valid under D-Wave early license. Yeah. Let me close all these tabs. Close. Having a clean browser is important. Contrary to a lot of, you know, the popular opinion out there. Okay, creating the configuration file. Configuration file not found. This is going to be the path, whatever, yeah. Configuration path does not exist. Create it, yes. Create profile, create new prod. Your API endpoint URL. Okay, so let me see. Maybe I'll do that off screen so you don't see. You can't just because if I reveal some stuff I shouldn't, then it's not nice. Basically. Let me log into D-Wave. D-Wave. Because now I need to have some API endpoint URL, and I think I might have to actually log in here. So where is it? Where is it? How do I log in? I don't want to work on COVID stuff, man. The Leap thing. Where is that about Leap? Okay, here's sign up, log into Leap. That's what I wanted. Yeah. I don't know if I should get. I don't know if I'll get an access code thing in my email. I will. And so I'm gonna check it out. Well, come on. Access code. Are you there? Doesn't look like. Gmail. Nothing. I'll resend the code. Check your email. Cool. I don't know. I haven't got it yet. But yeah, I guess, and then there's the authentication code. And then I don't know what the default client class is. Is it QPU or I guess SW simulator? I will go with QPU. I really wanna. Damn, I'm not getting anything. Come on. D-Wave. Don't let me. Don't lose me. So this is crap commercials from Gmail. Nothing. Maybe it's in spam or something. Let me check. Where's spam? Here's spam. No, it's not in spam. Oh, now there you go. I think there is it. The notification just arrived, and it's going to be valid for 15 minutes. Thanks. Okay, cool. Submitted. Yeah, you're probably not seeing anything. Sorry. But now I'm in. Okay, cool. With the developer plan, and now I have the API token here. And how do I know what is the solver API endpoint connecting to Quantum Cloud services? To connect to a solver, you need a solver API endpoint, and that's what I need. So this is the stuff that but I think that is not private. But anyway, so I'll use it here. API endpoint URL, authentication token, and now that's the API token, which I'm going to copy and paste in here. Default client class. It's suggesting me to skip it. I don't know. I guess I'm going to skip it so far. It's thinking. It's thinking. But it's I have to admit it's fairly straightforward to set up so far. I don't know. And then that should be it, because then there's a default solver and blah blah blah. But what do I do next? So I go to next, and what do I do? Interacting with SAPI, that's the API endpoint. Yeah. The solver. Creating a configuration file. I've created already a configuration file. Verifying your configuration. Okay, so then the next thing to do is, to ping D-Wave and check everything's working fine. Then this command just submits a random problem. We can also do that. No, we're not going to do that. So we have the solvers. Okay, cool. Is this doing anything or not? It's still thinking. Come on. Come on, D-Wave. So then we're going to have... So then we're going to have the play with pink, and then what do I do? Okay, so this is the actual... okay, once you have selected and configured a solver, your code queries its parameters and properties as attributes. Sample parameters, solver QPU. Okay, so basically that's what you do next. I guess I can just then use the code directly of how to solve a problem. So an actual example, Cubo example, D-Wave Cube example. It's still thinking. I don't know what it's doing. I've given it the authentication token, and it's just there hanging, and then it says default client class, and I just click skip. Oh, I can't. Apparently, I can't skip. Okay, I'll just call QPU. Sorry, I thought it was thinking. Default solver. Default solver. How do I know? Can I just skip these as well? It's asking me for the default solver. Skip. Can I just skip these as well or not? Yeah. Configuration saved. Okay, cool. We're good to go. Configuration saved. So let me bring this back here. If I do D-Wave ping, what's going to happen now? Is it going to ping D-Wave up successfully or not? Yeah, it seems like. Nice. Nice. It's working. I like it. So I guess it's time to just get going, right? Like I can, in theory, submit the problem. Like I have the Cubo. cubometrics example. I just want the basic. Is there code in here or not? It's probably not code in here. I don't want to have to open the IDE to just copy the code. Although I might have to do that. Blah blah blah. Dictionary, my cubo array. What is these? Oh shit, what is these, man? It's a huge cubo. From D-Wave, Q-solver, Q-solver. No, that's not what we want to do. I'm looking for any reference code. I don't know what the imports are. I don't know any of these. Examples. Advanced examples. No. Intermediate examples. Map coloring. But again, those are not like... I want to just... damn it. Let me just go back to D-Wave here and IDE workspaces. I'll just open up one of the workspaces because I remember that there are some examples simply, and I'll just copy the code from there. I can't wait. So come on, load. It's loading, it's loading, it's loading. D-Wave leap. Like the thing is, it takes a considerable amount of time to do that and learn all that from scratch. Okay, so I got this here, but now I have the Cubo. But I have it in the dictionary way. Which probably it's a better way to do that. Where did I get the code from though? Like I got the code from somewhere, I remember. Can I just... Example projects. So those are example projects. The maxcat problem, loading IDE. Come on. I want I just want an example of D-wave. Look, D-wave cubo matrix code example. Read the docs of business. Um, two illustrative examples. That's not what I want. Cubo, traditional cubo versus D-wave cubo. This is the, I keep going back to this one. So, symmetric upper triangular, main diagonal terms, correct finish, upper off diagonal terms. That's what we want. Also won't work, but it's not. So here we have from D-wave. The PQM form. Binary quadratic model. Come on. I have the matrix and I want to send them matrix. It is possible to solve cubes directly with many D-wave tools. D-wave samplets with a sample cube function. D-wave sample cube function. D-wave. Can I just search for the function? Maybe I'll just find some example. D-wave sample as sample cubo. Didn't I have anything in my notebooks here? What did I have here? Maybe I had something in the portfolio Chicago. No, I was just getting the data and trying to do stuff with it. That's it. That's all I did. But I never actually wrote anything in here. Oh, there's some examples in the repo, so I probably should just do these. Graph, maze, Sudoku. Knapsack. Failed. Main file. So what does it do here? Knapsack BQM. Builds. Okay, that's building a QBM model. I just want to send it a matrix, man. I just want to send it a matrix. How I cannot find an example of these? Sample cubo. Oh, sorry, I was there. Stupid. D-wave code example. D-wave sample cubo. D-wave cubo. So I'm gonna probably find it somewhere else. That's awesome. Handbook, blah blah blah. A tutorial on formulating and using cubo models using D-wave. Oh, so there's an actual tutorial. So there's a whole paper here on how to, okay, how to construct those. Nice. Okay, cool. So we can come to it later. Okay. But I'm just getting pieced right now. Auto embedding. I just want a simple. I want to know what I have to import, and then what do I have to just, you know, send to it. Come on. Knapsack. Antenna selection. Let's see. Let's go to antennas Python file. D-Wave network, blah blah blah, add edges, graph. So it's creating a graph. It's D-Wave sampler. How to submit a Cubo matrix to D-Wave. Please help me. So there's the icing thing, the Q representation, the BQM representation. Oh, here there is some example. Okay. Used by samplers such as the D-Wave system. These models are under use in solving problems on D-Wave systems, so key concepts, implementation, quadratic model, keyboard, samplers and composite samplers. Maybe here's exact solver runs a similar annealing, null sampler. What do I want? Sample set is not what we want. Binary quadratic models. Class. Like I thought, come on. I don't know. I'm like 15 minutes just looking for this damn thing, and I can't figure out how to submit a Cubo matrix. Let's just maybe go through the it's unbelievable. D-Wave systems, D-Wave. Let me take one of these off screen for a second. Let me open D-Wave. Log into D-Wave again. D-Wave. Bleep login. Is it gonna remember me, or I have to do again the two-factor authentication? No, I don't. Good examples. Interact with our demos, access our resources. So we'll do these resources. What is in resources? Applications, blah, 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 blah. Code examples. No, I was in here already. Yeah. Simple ocean examples. So please let it this be what I'm looking for. Let it this be what I'm looking for. Yes, I think so. Yeah, okay, but that's from Cubo. Okay. That's kind of, let's take these and let's work it out, okay? So let's take these and let's say that I want to go and here. So let me just import the D-Wave stuff first of all. First and foremost, import the D-Wave stuff, then we do all the things in here, and now we have our Cubo. And now what we need to do is, basically binary quadratic model documentation. Maybe we can just feed, the matrix. Fromizing from Cubo, from a Cubo model. From Cubo. So what is this method doing? But it takes a dictionary, and I don't want a dictionary. I just wanna. Oh, God. I just don't want a dictionary, but I might have to create one. Great. I don't want a dictionary. I want a matrix. Can I just not give it a matrix? Binary quadratic model. D-Wave. Oh, there you go. From NumPy matrix. Oh, there is these. Ah, nice. Okay. Optional offset interactions. Okay, cool. So there is these. So from NumPy matrix, and then it's a Cubo. I have no idea what this is gonna work out. The imports worked out, but these, I don't know. So I do all this stuff. I get the sampler, and then I print the sample set. So we're gonna actually not print any of these. If that, whether this works or not, I'm gonna stop here, I guess. But let me first run this. Okay, printed this thing, yeah, but I want this to print the D-Wave. Oh, finished already? Oh, nice. Okay. There you go. It seems it's worked actually. And if I go back to the D-Wave console here, go to the dashboard, take the dashboard down here so you can see it. Yeah, look at these. So there's September 10, I don't know why 2 jobs. Time used, problem submitted. Dark cube view. Submitted 3. Okay, but they are there, right? So, wow. Okay, so I actually made it. I did. Okay, so now I have the 5 variables in here, and now can I? Let me see if I did this well. So what happens if I say now I have 6 assets? I'm gonna double the amount of assets. Is this gonna work or break? Okay, now I have more qubits. Oh wow, that actually worked. Yeah. Okay, cool. Nice. Okay, so what is left to solve here is really just maybe I should comment this out next time. But so what's really left to do here is, or you know what? Actually, I should take these. I should take these out of here. I should keep printing these, and actually, what I should do is I should add another cell below, which basically does the actual thing. So, and these just prints the QO. Nice. Okay, perfect. So we got it working end to end with D-Wave, and yeah, that's just solving, I guess, crap. But we can generate the problems with the ends and the stuff that whatever we want, and yeah. And so now I just have to figure out how to solve the rest of the equation. So basically, get the cost, the transaction cost stuff, and also get the this Lagrange thingy for the constraint, because that's going to make sure that we have the constraints that we cannot have more than K investment. And yeah, let's see if we can solve that in the next video or two, and then we're ready to go and move to the other algorithms that compare these. And then at some point we'll compare the Chicago quantum one as well. But it's yeah, I like it. Okay, cool. It's just it takes a while to get used to the whole expression generation thing, or building expressions with SymPy. But yeah, then once you get it, then it's easy, because then you just have to expand it, and then once you expand it, you can generate a QO out of these, because you can just basically query for all that. So I'm gonna basically commit all these as well. God. Git add everything, git commit. What happens? Git commit. So basically, what have I done? So I have just basically plugged the wave in. Push and bye bye. Thanks for joining. I hope you enjoyed it. Yeah, it's learning a lot, definitely.